Hey everyone. Hey, as promised, we're going to jump into a new section. So we're going to talk about 4.3, patterns and nonlinear functions. If you would, go ahead and get out your notebook. The color of the day is anything that I have written in the notes. So you get my hand gestures. So go ahead and get out your notebook. I'm directing airplane traffic. I need you over here to get out your notebook, and you over here to get out your notebook, and you over here, and those of you in the back, get out your notebooks. Don't listen to my wife. Everyone get out your notebooks. The main idea what we're talking about today is comparing the linear functions that we were talking about recently, those cool shapes, those cool graphs, the tables, all that, to nonlinear functions. So what's the difference between linear and nonlinear functions? Linear functions, the graph is a non-vertical line or part of a non-vertical line. So there's an example right there in front of you. There's an example of a line there. It's a horizontal line. Remember, it's not vertical, it's horizontal, so it's still good. These dots on my graph here, this is part of a non-vertical line. Those dots would make a line if I connected them. I didn't, but it's still cool. And then this last one over here, this is what you know is kind of a standard line. I'm going to pause for a bit so you guys can copy these down in your notes. So go ahead and do that. You don't need graph paper for this, just do some rough sketches. So I'll let you stare at the back of my couch while I go make some popcorn. I'll be right back. All right. I think you've had enough with this slide, so we're going to go ahead and move on to the next one. Next, we have nonlinear functions. Nonlinear function whose graph is not a line or part of a line. So looking at our three examples that we have this example over here, my first example. This is actually called an absolute value graph. It's just missing to connect those points. Blood rushing to my head. So this is the first one. That is not a line. In fact, if I connected these, it would be like two lines intersecting. This makes a cool V-shaped graph. This one over here is called a parabola. Quadratic. You study these heavily in Algebra 2 land, like huge. In fact, that's what I'm doing right now in Algebra 2 land. And then this over here is actually called a cubic function, x cubed. This also is not a line or part of a line. So again, oh, that looks pretty cool. That's beautiful. So go ahead and copy these down. Be right back. Alright, we got the second bag popping, so we are good to go. Let's see, jump to the next slide. So now we're going to talk about classifying functions, either as linear or nonlinear. The two tables below are examples of both linear and nonlinear, should say functions. Who made this? What's a way to quickly figure out if the graph is linear or nonlinear? Well, to actually graph it. So go ahead and make these two tables, and then again, we're going to do a rough sketch of a graph. And you notice that these two tables are vastly different than some of the stuff we've been talking about. Some of the stuff that we've been talking about has been like nice examples, like, oh, 1, 2. It's not how it is in real life. In fact, if you look at the example with the radius and the area, radius is 2 inches, area is 12.57 inches for 50.27. That's really what you deal with. If you're like working on pizzas, or in my case, working in the basement, we're working with like decimals and trying to round as much as possible, and man, it's just crazy. So go ahead and copy these down in your notes, the tables and the words. I'll wait. Popcorn style.
It's a long way down.
I got making good popcorn. They understand. They know. Hash brown popcorn. I'm assuming it's going to take a while to make the graphs too. I mean the tables. I don't even have a graph chart yet. Next. That's my wife's feet, in case it's in vision. You guys can see it. I don't know. Can't see if you guys can see it or not. Yes, it is popcorn. It's delicious. My wife wants some. That's why I popped 2 bags. I won't see any of this. Notice how I just handed that over? Guys, that's a good trick technique. If they want something, just give it to them. Next slide. So here's the graphs of both the functions. So you can see the pizza area, the nonlinear one, and the sauce cost, that's a linear one. You can kind of see visually what's going on here with the pizza area one. It's going a little bit more. Now it's getting really big. I couldn't really connect these to make a line. It looks like it makes kind of like a, I don't know, like a slope, kind of like a hill. It's kind of going up a hill. The sauce cost, as it's moving up like a line. If I connected those dots, it'd make a line. The pizza area is growing more with each number, where the sauce cost graph is increasing by a steady amount with each number. So there you go. There's that. You want to say hi to my students? Everyone say hi, Mrs. Brummond. Luke, do you want to say hi to my students? Come here, bud. Say hi.
Hi.
Okay, now go to bed. Good night, buddy. Oh, yeah, I heard you making laser sounds too. Pew, 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 pew. We can also represent patterns of nonlinear functions. So here's an example. The example that they give in the book, number of edges on the block. So edges is like how many basically blocks there are in the line. So for the first one, if there is one block in the line, then the total number of blocks there is 1. So I make that as an ordered pair, 1, comma 1. I was able to locate a picture of this. It took me a long time to create this in Minecraft. Actually, it took me a long time to get the screenshots because I couldn't find them. However, there's an example right there. It has one edge, and it's 1, 1. Excuse me, number of blocks on the edge. There's only one block on this edge. This next one, there's 2 blocks on the edge. 1, 2, 1, 2, and you can't see it, but on the top, 1, 2 as well. 1, 2, 1, 2, 1, 2. Same thing. There's a total of 8 blocks in there. 1, 2, 3, 4, 5, 6, and then you can't see the ones in the back. 7, 8. So that's 2, 8. And the next one you got 327. I'm not going to count each one of those because it's a lot, but 1, 2, 3. And then you got 1, 2, 3 this way, and then 1, 2, 3 up. So there's your 27. Let's use a table now to make a graph. Then we can use the graph to determine if this is a function is linear or nonlinear. So here it is. The points plotted in the graph does not make a linear function, a line or look line-like. Therefore, it is not a therefore it is not a nonlinear function. Therefore, it is a nonlinear function. Man, that's really hard to say. So going back here, because I think I accidentally clicked and I didn't mean to. Go ahead and take about, I don't know. Let's do a minute, finish up. Delicious. Man, put a lot of butter on this. Oops. Good though. 10 seconds. Okay. All right. Moving on. So, I already talked about this. I'm just going to give it a minute. Just do a quick sketch. Doesn't have to be amazing, guys. And gals. Luke, go to bed. Three, two, one. All right. So the next thing, let's go ahead and copy this down, just like you've been copying down everything. Writing a rule to describe a nonlinear function. So it's a little bit different than what we were talking about with how you could look at how much it grows each time. Then you could use that as the coefficient in front of the variable when you get your rule. It doesn't quite work that way. In fact, let's see if I can start drawing here. There we go. And pen. What rule produces 2 given a value of 1? What does that mean? That means what rule gives me 2 when I put in 1 in for the variable? So in this case, when I put in 1 in for the x. So if I do, so 1 plus 1, that'll work. That gives me 2. What rule produces 4 given a value of 2? Plus 2, that'll work. Are these rules the same? No. Bummer. What's happening each time? Well, it looks like it's going from 2, 4, 8, 16. Oh, looks like it's actually like doubling each time. It's going up by 2 and then 4 and then 8 and 16 and 32. So it looks like it's going up by like another 2 each time. So like it's going up by 1, 2, and then it's going up by 2 times 2, and then 2 times 2 times 2, and 2 times 2. Huh. So that 2 is getting bigger and bigger each time. That's actually an interesting thing that we haven't talked about yet, and that is y equals 2 to the x power. Now, we've never seen this before, but this is huge in computers. This is how computers operate. In fact, this is how computers get their RAM or their operating speed. Computers work by on and off. That's it. That's how computers operate. Everything within the computer is either an on switch or an off switch. That's how it's toggled. So it's either got a value of 0 or 1. Well, that's two different values, 0 or 1. So everything in a computer operates off this 2 philosophy. That's why all of the cool things you talk about a computer, it's all kind of divisible by this number, this y equals 2 to the x power. Pretty crazy business. Here's another example. Writing a rule to describe a nonlinear function. Go ahead and copy the table down. Down to like half my popcorn. Parents will ask you, what'd you learn in school today? Well, I watched my teacher stuff his face with popcorn. You can also say that I taught you functions and nonlinear functions and patterns. That'd be nice too. All right. What rule produces 1 given a value of 1? This is kind of weird. What rule produces 1 given a value of 1? Well, 1 equals 1. That's it. What rule produces 4 given a value of 2? So 4 equals 2 plus 2, or 4 equals 2 times 2. Are these rules the same? No, these aren't the same. What's happening each time? Okay. So far we've been thinking linearly, and this is kind of how our brains naturally work. However, sometimes you gotta think outside the box. Instead of looking how much it's grown, think about what numbers or what operations can we do with 1 to get 1. Well, you guys know that we've got plus, minus, multiplication, and division. However, back in middle school land, you guys learned that you could do x squared and the square root of x. This is actually an example of one of those. It is x squared. So that's actually our rule each time. Y equals x squared. Sweet. Parabolas. No, if you can hear my wife talking in the other room. Here's a chance for you guys to work on your homework. If I'm in the room, I'm probably going to jump in and start talking about some other stuff. So, as always, go in for the bro fist. I mean, fist bump, fist bump.